everyone. I hope you're well and safe. I wanted to work a combinatorial proof. We've been having some difficulty with these lately, and a couple of major things about proofs in general. Whenever you're trying to prove something, there's two things you cannot do. One is you cannot assume it's true before you start the problem, because then you're already done because it's true. Secondly, if you're trying to show an equation is true, you cannot simultaneously work both sides, because again, that means you're assuming it's true before you start, and you can always make it work in the end. I can prove any false statement is true if I start with the assumption that they are in fact equal. That's not a contradiction. You're starting with a lie, and you're going to finish with a lie. So we want to work this one through. So generally, you choose one side or the other. It's logical to choose the more complicated of the two sides, and then manipulate the factorials. So on the left side, we have 2n plus 1 factorial over the difference of 2n plus 1 and r plus 1, which would be 2n minus r factorial, r plus 1 factorial. On the right side, I'll leave some space here, 2n factorial over 2n minus the quantity r plus 1, so that'd be 2n minus r minus 1 factorial, r plus 1 factorial. Now I'd like to be able to combine these. In order to do so, I need the denominators to be exactly the same. This factorial term is one value higher than this one. These are the same. So what I need to do is figure out what I need to multiply by. So I notice in this case here, I'll start with the fact that 2n minus r factorial is equal to 2n minus r times 2n minus r minus 1. So in order to make these denominators equal, I will multiply numerator and denominator here by exactly the term I need, which would be 2n minus r over 2n minus r. Now, when I do this, I can now combine these terms, and I can add numerators. And what this will give me is something of the form on top, 2n plus 1 times 2n factorial minus 2n minus r times 2n factorial. All of this over 2n minus r factorial, r plus 1 factorial. So now I have to figure out a way to manipulate my numerator to get it into something smaller. But notice I have a 2n quantity factorial in each term, then I can factor that out. So that means that my numerator will be 2n factorial times 2n plus 1 minus 2n minus r over my denominator. But if I notice, the two n's are going to cancel, and I will be left with an r plus 1 on the top. So my numerator right here is going to be 2n factorial times r plus 1. Notice I have an r plus 1 factorial on the denominator. Well, we know that r plus 1 factorial is equal to r plus 1 times r factorial. So as a result, I'm going to go ahead and erase the stuff up here. As a result, at this point, we've got 2n factorial times r plus 1 over 2n minus r factorial, r plus 1, r factorial, which conveniently leads us to this. I'm sorry, r factorial. I don't want to do this one again. And if I do a really careful analysis, the terms on my denominator add up to the 2n, so we have in fact produced the right-hand side, so we're finished. Now there's a couple of small details we want to pay attention to, and that's in the expansion of the factorials. This problem was very, very busy, and there's nothing about the solution that's particularly important. It's the path. We started with one side, we concluded the other side, therefore we know it's true. Now some of the pitfalls that we run into if we're not careful is when we're removing factorials. Simple statements like this. If I said 10 factorial, I know that's 10 times 9 factorial, which is 10 times 9 times 8 factorial. These kind of statements are very useful. The problem is when we have the larger factorial terms. So I might have a statement like 2n plus 2 factorial on top and 2n factorial on the bottom. And I'm trying to reduce this. If I'm not careful, I may say something that's not true. So right now I've got 2n plus 2, let me erase this, 2n plus 1, and then 2n factorial. On the bottom I have 2n factorial. This is a very simple cancellation, but what I notice a lot of people make the mistake of doing, I'm going to do something terrible right now, I'm going to remove the parentheses and write it in this form. These quantities are not even similar quantities. They're quite different and nothing will cancel. The parentheses are very, very critical, and if I try to do this, I will get a very different numerical answer. So when evaluating factorials, we have to be very careful, in particular to the details. Anyway, I hope this helps.